This is section 5.6, which is the law of cosines. We're going to talk about deriving law of cosines, solving triangles, which are SAS and SSS, and triangle area and Heron's formula to find the area, and applications. Okay, so law of cosines works if we have triangles that are side, 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 or side, angle, side. So, again, the angles would be opposite your lowercase letter sides. And so these are, if you have this, these are all if it's side, angle, side for these three formulas. So you can see that they're solved for a side or a square of a side. You'd have to square root when you find the final answer. And then what you can do is you can take each of these and rewrite them so that you can find an angle. So to use if you have side, side, side. So like if we take the first one, we could solve for cosine of A, which would be B squared plus C squared minus A squared over 2BC. And then you can apply that to the other two as well. So that's if you have all three sides and are looking for an angle. Okay, so example 1 is side, angle, side. So I always like to draw a picture here. So here's my angle C, 25, A is 10, B is 4. Okay, so we are trying to find side on this. We're trying to find side C. So we're going to use C squared. We're going to use that formula. So it would be 4 squared, 10 squared plus 4 squared minus 2 times 10 times 4 times cosine of 25. Okay, so when we do that, we get that C squared is 43.495, and then you're going to want to take the square root of that, and we get 6.6. Again, be careful of what you're rounding to. So that side is 6.6. So then we could, at this point, we could switch back to law of sines. However, law of sines, if you think about it, does not differentiate between acute and an obtuse angle, where law of cosines does. So because of that, it's almost better until you get until you're sure which side is going to be, since we don't know A. See, A is going to be our biggest angle. Since we don't know if that's obtuse or acute, it's almost better to use law of cosines, because then it will give you the correct angle measure. So I'm going to do cosine of A is 4 squared plus 6.6 squared minus 10 squared over 2 times 4 times 6.6. So this is cosine. So you're going to get that cosine of A is equal to negative 0.77. So then you do the inverse of cosine. So inverse cosine of negative 0.77. And we get that A is 140 degrees. So because of that, if you had done law of sines, you would not have gotten 140. So that's why if you want a foolproof way of making sure you're getting the correct angle, I would use law of cosines. Okay, so we have 140, so we can subtract we can find B using 180 minus 140 minus 25, we get 15 degrees, and then we already have all three sides, so that solves our triangle. Okay, then solving a triangle side, side, side. So the important thing to note, for the same reason that we talked about with cosine differentiating between acute and obtuse, but sine not, I would recommend, just in case you decide you want to use law of sines, I would recommend, I don't know what I just did. I flipped between letters and numbers. Okay. So C is 5, trying to talk and teach at the same time. A is 9, B is 7. There we go. Okay, so we have side, side, side. So I would always recommend, when you are trying to find an angle, always start with the biggest angle. And remember, you'd find the biggest angle by looking at which was the biggest side. So the biggest side we have here is A, so I'm going to find angle A to start with. So angle A, so cosine of A would be 7 squared plus 5 squared minus 9 squared over 2 times 7 times 5. So we get cosine of A is negative 0.1. We do our inverse cosine, so we get that A is 95.74 degrees. Okay, then again, we could do law of sines now because we know that A is obtuse, so therefore none of the other two are going to be obtuse, so we're safe to use law of cosine or law of sines if we want to. But also you could just do law of cosines again. So let's just to practice that. So cosine of B would be 9 squared plus 5 squared minus 7 squared over 2 times 9 times 5. So then we would do the inverse cosine of that, and we get 50.70 degrees. So then to find angle C, we can subtract those two from 180, and we get 33.56 degrees. Okay, so that is side, side, side. So now we can talk about finding the area of a triangle, so side, angle, side, or side, side, side. So if you have side, angle, side, if you know one of the angles, you could use this formula, 1/2 BC times sine of A, or 1/2 AC times sine of B, or 1/2 AB sine of C. Heron's formula is used if you know all three sides. So what you have to do for Heron's formula is you need to calculate S, and S is what is the semi-perimeter, so the perimeter of the triangle, half of that. So it's A plus B plus C divided by 2, and then you use down here the formula to find the area. So here's an example of that. So we have a triangle. Doesn't really matter, A, B, C, but we have 10, 12, and 14. So the first thing that we would do is we'd find S by doing 10 plus 12 plus 14 divided by 2, and we get 18. So then we would apply that into the area formula. So it would be 18 times 18 minus 10 times 18 minus 12 times 18 minus 14. So we get the square root of 3,456. We can reduce that into 24 square root of 6, which is approximately 58.8. And we would say square units because we don't have a measurement unit on here. So 58.8 square units. Okay, so that is law of cosines.